Welcome everyone to a new episode of Science. Today we will talk about earthquakes. As you can see, the ground shakes and everything started to fall apart. What's an earthquake? The ground trembles, dishes fall off shelves, walls and buildings come crashing down, highways buckle and bridges are torn apart. All these are events caused by an earthquake. So what's an earthquake? An earthquake is a sudden movement of Earth's crust. An earthquake is a sudden movement of Earth's crust. The rock on both sides of a fault, as you can see, this is the fault. The rocks on both the sides of a fault, they are pushed and pulled by forces in the crust. Usually the rocks on both sides of a fault are stuck together, but when the layers of rock that are stuck together suddenly slip, an earthquake takes place. As a model, press your hands strongly together, then try to move your hand past each other. In this case, it's not easy to do, but if you built up a strong enough sliding force, you can slip your hands or your hands will slip. Slipping along a fault begins beneath the Earth's surface. Most earthquakes occur at depths of less than 80 kilometers. However, earthquakes can occur as deep as 645 kilometers. Can you imagine that? The place where the slipping begins underneath the Earth's surface is called the earthquake's focus. This part is the focus of an earthquake. This is the place where the slipping first begins. This is called the earthquake's focus. Then waves of energy ripple or vibrate outward from this focus in all directions. Waves of energy ripple or vibrate outward from the focus. When these waves reach Earth's surface, the waves spread out from a point directly above the focus. This point is called the earthquake's epicenter. So when the waves of energy produced from the focus reach the Earth's surface, they spread out from a point directly above the focus. It is called the earthquake's epicenter. People first feel the ground shaking at the epicenter of the earthquake. Here is the epicenter, just above the focus on the Earth's surface. The waves move like ripples on a pond. As these waves, if you can see it, as these waves, they are spread along the water surface. So also the waves of energy produced by an earthquake, they move like ripples on a pond. The waves make the surface and anything on it move. The amount of damage caused by an earthquake depends partly on the amount of energy released at the earthquake's focus. So the amount of damage caused by the earthquake depends on the amount of energy released from the focus. When more energy is released, more damage is likely to occur. Earthquakes happen along the boundaries of tectonic plates because the pressure from the movement of plates pushed on nearby faults. Alaska, Oregon, Washington, and California are near tectonic plate boundaries. So most of the earthquakes in the United States happen in these states. Look at this map here. This map shows the locations of earthquakes and the boundaries of Earth's tectonic plates. We already studied the boundaries of tectonic plates. These are the black lines. But if you can see this label, or this is the key to this chart, the silver is very low places that have very low earthquakes. The light yellow is low, the yellow is average, the orange is high, and the red is very high. As you can see in these parts, this is where the earthquakes are centered or located in all the earth. Okay, what waves do earthquakes make? Let's see. At 8:50 a.m. on October 8, 2005, a powerful earthquake struck the country of Pakistan in Asia. Within minutes, waves from that quake reached seismometers in the United States. How come? So what is a seismometer? A seismometer is an instrument that detects and measures waves produced by an earthquake. So this is a machine used to measure and detect the waves produced by an earthquake. So what are the waves produced by an earthquake? It produces three different kinds of waves: primary waves or P waves, secondary waves or S waves, and surface waves or LG waves. Okay, let's see. Primary waves. Primary waves move the fastest. Primary waves pass through both the solid and the liquid layers of the Earth. As you can see, the primary waves, the red one, they spread through the solid and the liquid layers of the Earth. Primary waves move back and forth as rocks squeeze together and spread apart. As you can see, this is the movement of the primary waves, back and forth as the rocks are squeezed together and they are far apart. Okay, then the second type of waves produced by an earthquake, this is the secondary waves or S waves. Secondary waves travel about half as fast as primary waves. Secondary waves move only through Earth's solid layers. As you can see, the secondary waves or S waves, the L ones, only through the Earth's solid layers. And the secondary waves move up and down. As you can see, the secondary waves, they move up and down. And then the third type of waves, which is surface waves or LG waves. Surface waves are the slowest moving waves. They travel along Earth's surface like waves across an ocean or ripples across a pond. The surface waves cause the most damage. But we have one question, which is, how did scientists know that the earthquake on October 8, 2005 started in Pakistan? So we will talk about locating an earthquake. Seismometers can be used to pinpoint or locate the exact location of an earthquake. The difference in time between the arrival of P and S waves at a seismometer station gives the distance to the epicenter of the quake. How come? However, this difference cannot find the exact location. But let's see. For example, the distance from the seismometer station to the quake epicenter is 1,000 kilometers. Okay, so the epicenter could be anywhere on a circle with a radius of 1,000 kilometers from the seismometer station. Yes. To pinpoint the exact location, scientists need data from at least 3 stations. As you can see, this data is used to draw 3 circles on a map. The point where the circles meet, like this one right here, the point where the 3 circles intersect is the epicenter of the earthquake. But how is an earthquake's energy measured? Some earthquakes release more energy than others. Scientists measured the magnitude of the 2005 earthquake in Pakistan to be 7.6. So what's a magnitude? Magnitude is the measure of the amount of energy released by an earthquake. Magnitude is the measure of the amount of energy released by an earthquake. So what scales do we have? The first scale is the Richter scale. Richter scale. The Richter scale measures the magnitude at the epicenter. The Richter scale rates earthquakes from weakest to strongest, starting from number 1. Each larger whole number indicates an earthquake that releases about 30 times more energy than the previous whole number. Meaning what? For example, a 7.6 earthquake releases 900 times more energy than a 5.6 earthquake because the difference between them is 2 on the Richter scale. And each one releases, each whole number means that it releases 30 times more energy than the previous one. So 30 times 30 equals 900 times more. Can you imagine this? Then what about the Mercalli scale? Mercalli scale. The Mercalli scale measures what people felt and what happened to objects at a specific location. The Mercalli scale earthquakes are rated in Roman numerals from 1 to 12, with 12 being the most severe, and here are the Roman numerals. The earthquake in Pakistan was 12 on this scale. Then this is a comparison between the Richter scale and the Mercalli scale. The general description, this is the micro earthquake. On Richter scale, it is less than 2. On Mercalli scale, it is not counted. Estimated number of earthquakes per year is 600,000 times. The effects not usually felt. Then a barely felt earthquake on Richter scale from 2.0 to 2.9. On Mercalli scale from 1 to 2. Estimated number per year, 300,000 earthquakes. May be felt by a few persons at rest. Then a generally felt earthquake on Richter scale from 3.0 to 3.9. On Mercalli scale from 2 to 3. It happens 49,000 times per year. It felt noticeably by people indoors. Then minor earthquakes on Richter scale from 4.0 to 4.9. On Mercalli scale from 4 to 5. It happens 6,000 times per year. It is felt indoors by many and outdoors by few. The furniture moves and books fall off shelves. The moderate earthquakes on Richter scale from 5.0 to 5.9. On Mercalli scale from 6 to 7. It happens 1,000 times per year, felt by nearly everyone. Windows, dishes, and glasses break. Then large earthquakes on Richter scale 6.0 to 6.9. On Mercalli scale from 7 to 8. And it takes place 120 times per year. The buildings partially collapse. And major earthquake on Richter scale from 7.0 to 7.9. On Mercalli scale from 9 to 10. It takes place 18 times per year. Buildings shift off of their foundations. Then the great earthquakes from 8.0 to 8.9 on Richter scale and from 11 to 12 on Mercalli scale, it takes place only once a year, and its affect most buildings and their foundations are destroyed. Then we have something called aftershocks. Aftershocks are sometimes felt after the main earthquake. Aftershocks are earthquakes with lesser magnitude. Earthquakes with larger magnitudes have more aftershocks, and these aftershocks have larger magnitudes. Then we come to another term or another phenomenon that is named tsunamis. As you can see, this is a tsunami. So what is a tsunami? When an earthquake occurs underneath the ocean, a wave of water is pushed upward and outward in all directions. The water rushes across the ocean at speeds from 500 to 1,000 kilometers per hour. Can you imagine how fast it is? These waves carry tremendous amounts of energy. Then, out at sea, the energy is spread through deep water, so the wave is not very tall. As you can see, this is in the deep water. But as the wave reaches shallow water near shore, it is yet the same amount of energy, but it is spread through much less water. So the height of the wave increases, as you can see, as it reaches shallow water, the same amount of energy, but in a less amount of water. So the waves becomes huge. This makes huge waves called tsunamis in places such as beaches and harbors. So what is the meaning of the word tsunami itself? It's a Japanese word that means waves in port. Tsunamis usually occur after underwater earthquakes that are greater than magnitude 6.5 on the Richter scale. Tsunamis can be predicted by detecting such earthquakes. In the Pacific Ocean, a system of instruments that measures the changes deep in water. When a tsunami occurs, a warning is sent out to the areas at risk. A global tsunami warning system is being planned to detect future tsunamis. But how can people prepare about earthquakes and tsunamis? People cannot stop an earthquake from occurring. Yes, this is for sure. However, they can take steps to reduce the damage caused by the shaking during an earthquake. Sometimes people can be warned about a future earthquake. If people are caught in an earthquake, they can seek a safe place and be aware of the dangers. Damage to buildings is reduced by placing layers of rubber and steel between a building and its foundation. This is how to reduce the damage caused by an earthquake to the buildings by placing the layers of rubber and steel between the building and its foundations. These layers cushion up and down motions but still allow the building to move from side to side as the ground moves. Cushion up means it acts like a pillow below the building itself. In an earthquake, a building on top of these layers of rubber and steel, it will sway or shake a little bit, but it is much less likely to be damaged. Most newer buildings in the US cities such as Los Angeles and San Francisco, they have been built using these methods, and this is one of the buildings. But people, before an earthquake, they should secure objects that might fall, and people can identify safe spots to use as shelter during an earthquake, such as under a sturdy table or a kitchen counter, as you can see. Predicting an earthquake is not easy to do. Instruments have been placed throughout California to detect possible signs of an earthquake, such as bulges or swellings in the ground or changes in the angle of the ground itself. But how soon will an earthquake happen after these changes are observed? Actually, it could be hours, days, weeks, or months before enough energy builds up for the ground to actually shift. This makes predicting earthquakes difficult. When earthquakes can be predicted, people have time to seek safe shelter before the earthquake strikes. But predicting a tsunami is easier because it takes place after the earthquake, because it follows an earthquake that can be felt using seismometers, the PNS waves. People warned of a coming tsunami can seek shelter on high ground away from the shorelines where the huge waves of tsunami will hit the shore. And here we come to the end of our part. Hope this part is understood. Thank you and see you in the next episode. Goodbye.